Let's take a look at these examples. We have to convert them again. We have to write weights first above every single bit. So I have 1, double of 1 is 2, 4, 8, 16, 32, 64, 128. In order to find the decimal value, we're supposed to add the weights which are above ones only. So I have 128 plus 64 plus 16 plus 2 plus 1. We're supposed to add them up. 8 plus 4 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 21. 4, 6 is 10. Plus 1 is 11. And carry 1. 1 plus 1 is equal to. So this binary number is equivalent to the decimal 211. Let's take a look at another example. Again, we're supposed to write the weights first. 1, 2, 4, 8, 16, 32, 64, 128. Again, we're supposed to add the weights which are above ones only. So I have 128 plus 32 plus 4 plus 2 and plus 1. 8 and 2 is 10, 14, 16, 17. 3 is 6 and 1. So this binary number is equivalent to decimal 167. Now, let's convert this binary number to decimal. Again, we're supposed to write the weights. 1, 2, 4, 8, 16, 32, 64, 128, and I have 256 over here. Again, we're supposed to add the weights which are above ones only. So I have 256 plus 128 plus 64 plus 32 plus 8. 6 plus 8 is equal 14. Plus 4 is 18. Plus 2 is 20. Plus 8 is 28. 7, 9, 15, 18. 3 plus 1 is 4. So I can say that this binary number is equivalent to 488 base 10. So this is the solution to my problem.